Okay, so we've talked about pain relievers. We talked briefly about cold and allergy medicines. We've talked a little bit about how drugs are developed, medicines are developed over time. The next part is going to try to take all of these different medicines that we have and try to group them into what we call therapeutic classes. There are over 1,000 distinct medicines listed in what's called the physician's desk reference, and there's more being developed every single year. So we want to try to categorize them according to usage and according to structure just a little bit. So let's talk a little bit about the different uses of some of these different medicines. Centuries ago, the leading cause of death was infectious disease. So you get an infection and you die of that. Today, you don't hear that much about it. Today, the leading cause of death is heart disease and cancer. So let's go back in time. If you go back to the bubonic plague, back in the Middle Ages, 75 million people died due to the plague. Smallpox killed over 300 million people in the 20th century. But the last case of smallpox was back in 1979 because of our worldwide vaccine program. So we've developed these drugs to fight infection. So that's what we're going to start looking at. We're going to start by looking at antibiotics. Now, antibiotics, they were only discovered about 80 years ago. Think about the progress we've made in this in just 80, 90 years. So they were originally derived from certain molds and fungi. A guy by the name of Alexander Fleming back in 1928, he's a British scientist. He dealt a lot with this. He developed penicillin. Now, penicillin, it was discovered by serendipity. It was by chance. It has a great story. Go look it up. And actually, penicillin is down at the bottom right-hand corner. So you have a little plate, and on the plate there's a little zigzag that goes back and forth. That back and forth zigzag is a bacteria, it's Staphylococcus bacteria. And down at the very, very bottom, there's a white area. That white area is actually penicillin. Penicillin is a type of fungus. And if you notice, there's no bacteria that grows near that penicillin. Now, penicillin was used heavily to treat soldiers in World War II. So what you'll see is that the death rate due to infection starts to drop a lot. So common antibiotics, and antibiotics, again, they're used to kill other microbes. Penicillin is very common. Amoxicillin, you use that a lot whenever kids get strep throat. Tetracycline, that's used a lot for acne and other skin infections. And AZT is another antibiotic that's used. Now, one of the concerns that arose is what's called antibiotic resistance, where antibiotics have really been used too much over the years. And so the bacteria will develop a tolerance to the compounds that are designed to kill it. So sometimes they'll talk about superbugs in hospitals and that it's harder to kill different things. Right now, antibacterial soap is very popular, or the antibacterial gel type stuff. Some people have stopped using a lot of that because they don't want to promote this antibiotic resistance. I usually won't use the antibiotic gel unless I'm not near a sink to where I can really wash my hands. Washing my hands is a better thing. But some people like to use that a lot. So again, there's a little balance in here that's going to happen. But that's a little bit about antibiotics. This actually just comes out of your book. This one talks about AZT. And this was the very first drug that was used to treat HIV infections. And of course, HIV can lead to AIDS. This was introduced back in 1987. So down at the graph on the very bottom, you can see, let's see here, we have living with HIV infection, where you see this great increase back in the 80s until About 1989, 1990, it kind of flattens off and then it starts to increase again. But look at the AIDS death. That one's kind of interesting. So you also see this great rise in deaths due to AIDS, and then it drops dramatically in 1995. And what had happened back in 1995 is that these new drugs came out to try to help um, treat AIDS. It doesn't cure it, but what it can do is it targets enzymes in the immune system because we have a lot of immunodeficiency issues that occur with AIDS. So we're trying to treat some of those symptoms to allow people to live longer lives, hopefully more symptom free. So AZT was one of the drugs in this drug cocktail that they started to develop to give to people. The next therapeutic class we want to talk about is psychiatric. These are going to be used to treat mental and emotional issues. And a couple of the popular ones deal with tranquilizers or antidepressants. Tranquilizers are going to reduce anxiety. Often they're used as a muscle relaxant or a sedative. And these were first tested on lab animals back in the 1950s. A common class is a benzodiazepine. Xanax and Valium both fit underneath that area. An antidepressant is called an SSRI. It's selective serotonin reuptake inhibitors. So what we want to do is we want to enhance the mood for the depressed. We do so. Serotonin is in your brain, and we want to allow the serotonin to continue circulating in the brain. So that's what the antidepressant is going to do. We want to increase serotonin levels to help treat that anxiety and depression. But we do have some side effects. Prozac is a very common antidepressant that's used. But they have issues with nausea and also with loss of appetite. So everything has a side effect. There's a certain risk of taking anything. All right, so our next class is the steroidal therapeutic class. All of these have the same basic structure, but then we're going to add on different side groups. It's an organic 4-ring structure, so carbon-based. There's 3 rings that have 6 carbons, and then at the end, it has a little 5-carbon group. So right here in that little group right there, that letter D, there's 5 carbons. Now, these deal with regulatory activities in your body, such as sexual development, reproduction, metabolism, inflammatory processes, water retention, anything like that, regulatory activities in your body. Now, these we can classify. There's hundreds of different steroidal type compounds. They can occur both in nature, so they're in plants and animals, and you can also have synthetic ones, so ones that are going to be completely man-made. The corticosteroids, those are the ones that are going to be used to reduce inflammation. They're similar to cortisol. Cortisol is a steroidal hormone actually produced by your adrenal glands. They can help relieve pain and swelling due to arthritis. They can be used to treat asthma, so they want to reduce the inflammation in the breathing passages. And they can be used to help reduce the itching and inflammation caused by eczema. But everything has some issues. They can cause weight gain, insomnia, so you can't sleep, and you also have lowered resistance to infection. Anabolic steroids, these are going to be similar to testosterone. They're used to increase your muscle mass. So when they talk about bodybuilders using steroids, these are usually the type that they're talking about. So they want to have some sort of performance enhancing type steroids. You do get physical changes, so you get a difference in the muscle mass, and you also tend to have these very aggressive outbursts when this type of steroidal compounds are being used. So here is another steroidal compound that we're going to look at, and these are called the progestins. These start to get very, very confusing because you can use them in so many different ways. So these are going to be similar to progesterone, which is a hormone in your body. They're sometimes used as a mimic of that. They can be used to inhibit ovulation so we can prevent pregnancy, but you can also take progesterone to help help a pregnancy. Sometimes if a person has a tendency to have miscarriages, they'll actually give them progesterone during the pregnancy to help the pregnancy along. But you can also use these progestins, which is a progesterone mimic, to inhibit or stop ovulation so that you don't get pregnant. Like I said, these can get kind of tricky down here. At the very bottom, we have this picture of this Mexican yam. So this Mexican yam, in the 1920s, they actually isolated diazogen, which was then used to produce progesterone. So they found an actual way that they could start isolating these different compounds. It was back in the 1960s when the first oral contraceptive was produced or first marketed, and it had a combination of progestin, and a synthetic estrogen. And this is one of those areas that you can kind of get lost in all of the cons and pros and all types of things. Just be careful what you put in your body. All right, so here's a quick question for you. Steroids have a 4-ring base structure. And it turns out that is true. 3 of those rings are 6 carbons, and one of the ring has 5 carbons in it, and they're all attached to one another.